Okay, there are some focusing issues. I think I have it resolved. So, part 2, dependent events. So this is example 3, actually. Well, that was off the screen. But it is example 3. If Stan sees Wendy, there is a 70% probability that he will vomit. Presumably he's nervous or something. If Stan does not see Wendy, the probability of vomiting is 20%. The probability that Stan sees Wendy is 35%. And so the questions I'm going to be asking are, A, what is the probability that Stan sees Wendy and vomits? And B, what is the probability that Stan vomits? So pause the video here, assuming you need to copy it down. So these are not independent events. These events are dependent. So whether or not Stan vomits depends on whether or not he sees Wendy. If he sees Wendy, there's a higher chance that he's going to vomit. If he does not see Wendy, there's a substantially lower chance that he's going to vomit. So since they're not independent events, so before, remember, the formula was that the probability of A and B was the probability of A times the probability of B. But that's no longer the case. That is no longer the case. So what it's going to be is the formula becomes the probability of A and B is going to be the probability of A times, and you may or may not recall this, it was because right before we went off on our quarantine hiatus, but I had a vertical line. What that vertical line meant was that was the probability of B given A. So this is the probability of A times, so the probability that A occurs times the probability that B occurs given that A occurs. All right, so that's the formula we're going to be using here to an extent. So what do we have? We know that A is going to be that he sees Wendy. So that's going to be event A. And event B is going to be that he vomits. As a side, what am I looking for here? So what I want is, so for A, what I'm looking for is I want the probability of A and B. I'm looking for the probability that he sees Wendy and he vomits. For B, I just want the probability of B, which is not necessarily as easy as it sounds. Let's figure out what we have here. So that's 70%. What is that? So we have a couple of things. So first, we have our 35%. So what is 35%? So 35% is the probability that Stan sees Wendy. So the probability of A is 35%. Then what we have here is we have the 70% thing. If Stan sees Wendy, there's a 70% probability that he will vomit. So in other words, the probability of vomiting, given that he sees Wendy, is 70%. Or to write it in mathese, the probability that he vomits, given that he sees Wendy, is 70%. So that 20% now that's the probability that he vomits given that he does not see Wendy. And that's 20%. Is it weird that these don't add up to 100? See, in class I would pause and then somebody would kind of give the answer, and the answer is no. There's no reason why it would add up to 100. The one that would add up to 100 would be the probability of not B given A, plus the probability of B given A. That would add up to 100. Okay, so these are kind of our variables. Let's go back to our question. So the first question was, what's the probability he sees Wendy and vomits? So the probability that he sees Wendy and vomits, which I'm going to write like that, is the probability that he sees Wendy times the probability that he vomits given that he sees Wendy. Which in this case is going to be, there's a 35% chance that he sees Wendy. If he sees her, there's a 70% chance that he will vomit. So calculator. So it's 24.5%. If I have a mistake on one of my numbers, feel free to comment on it. I feel like one of those YouTube people are like, you know, if you care, subscribe, comment. Yay. The video is private though, so I shouldn't have too many views. Okay, so that was A. That was part A. That was fairly straightforward. Now B, B was asking for what is the probability that Stan vomits? And what that means, and what I figured out is we're looking for, that means we're looking for the probability of B. But notice we don't have probability of B. We have the probability of B given A, and we have the probability of B given not A. And essentially, what that means, there's two ways for him to vomit. He could vomit by seeing Wendy, and he could vomit by not seeing Wendy. Right? So let me make sure I don't say anything really horrifyingly bad. So, one way of looking at it is there's essentially two cases. So he could see Wendy and vomit. And the probability of him seeing Wendy and vomit, that's what we did over here, right? So that's going to be the probability of seeing her times the probability of vomiting given that he sees her, which is 24.5%. Then we want, the other way he could vomit is he could not see Wendy, but he could vomit anyway, because who knows? So what we want is the probability of not A and the probability of B given not A. So the probability that he doesn't see Wendy and the probability that he vomits given that he does not see Wendy. The probability that he does not see Wendy, so there was a 35% chance that he did see Wendy. So there's a 65% chance that he does not see Wendy. And the probability that he vomits given that he does not see Wendy from the original question was 20%. And we're going to calculate that. I think it's 13. 0.65 times 4. Yep. Which is 13%. And those are the two cases. And kind of like we've done elsewhere in the course, what we would do is, so the probability of vomiting is going to be 24.5% plus 13%, which would be 37.5%. So in this particular problem, the probability that Stan vomits is going to be 37.5%. I'm going to show another way of doing this exact same problem, more of like a different way of setting it up. It's going to hopefully give the exact same number, right? So we're going to call this method 2 kind of a tree diagram. But it's not going to be a normal tree diagram. It's going to be what I'm going to call a weighted tree diagram. So a weighted tree diagram, so it's going to start with a dot, like most tree diagrams. And then what could happen is he could either see Wendy or not see Wendy. And if he sees Wendy, he could either vomit or not vomit. And if he doesn't see her, of course, the same thing could happen. He could vomit or not vomit. And now we're going to put some numbers on. So the probability that he sees Wendy, which you may or may not recall, is going to be 35%. Which means the probability that he does not see Wendy is going to be 65%. If he sees Wendy, the probability that he vomits is going to be 70%, which means if he sees Wendy, the probability that he does not vomit is going to be 30%. If he does not see Wendy, the probability of vomiting is 20%. If he does not see Wendy, the probability of vomiting is 80%. Then what I want to do is do I have a green maybe? I do not have a green. Let's set. Okay. So what we're going to do is, over here, we're going to have this is kind of like are going to be our ants. So the probability of seeing Wendy and vomiting is going to be 35% times 70%, which we've already done. This will be our third time doing it. So that's 24.5%. The probability of seeing Wendy and not vomiting, you would multiply 0.35 times 0.3, which would be 10.5%. I actually cheated slightly. I didn't multiply it. What I know is that these two percentages have to add up to the 35. This and this we've already done. So the probability of not seeing Wendy is going to be this times this, which is going to be 13%. And the probability of not seeing Wendy and not vomiting is going to be 52%. So, to be clear, there's the pink numbers and the blue numbers, and they're not the same, and it's really important to keep track of which number is which. And often when people make mistakes here, it's because they've used one for another. Right? That's the probability of him seeing Wendy. That's the probability of him vomiting, given that he sees Wendy. This one's the probability of not vomiting, given he sees Wendy. This blue one is the probability of this and this. This blue one is the probability of this and this. Seeing Wendy and not vomiting. Not seeing Wendy and vomiting, that's the probability. Not seeing Wendy, not vomiting, that's the probability. Okay? I think we'll stop the video now, and I'll go into the next part after.